So before we go into our notes today for finding zeros with factored form, I do kind of want to run through what we explored in class. So if we jump back a little bit to our quick turn and talk activity, we did a quick comparison of this equation over here on the left, x squared plus 2x minus 3, and this equation on the right, x plus 3 times x minus 1. And the conclusion we came up with is they are the same. The graphs should look exactly the same because we have x plus 3 times x minus 1. If we actually did that problem, it would come out to be this standard form answer, right? We got factored form on the right, standard form on the left. So we can actually verify that in Desmos too if we wanted to. Plug in these two equations. F of x is x squared plus 2x minus 3. And f of x is equal to x, is it plus 2, sorry, x plus 3, x minus 1. You can see that the graphs are exactly the same. If I toggle them on and off, red and blue match each other. So we then did a quick kind of explore activity with Desmos. So it really helps to have Desmos to hone in this skill here. So head to this website here to use the North Carolina testing version so we get used to that. We are going to find the zeros of each polynomial using this equation. Now remember the zeros are our x-intercepts. So let's plug that in. We get f of x equals like x plus 2 times x plus 1. If we look at our graph here, we see that we have a 0 at negative 2. That's an x-intercept there. And a 0 at 1. So we've got two different zeros there, negative 2 and 1. Now if we build on this and find two more equations, x minus 3, x plus 4, x plus 6, we're just going to do this next one here. X minus 3. Got to delete some stuff. 4, 6. Okay. We might need to zoom out a little bit here to see our full graph. Wow, it really goes down there far. But if we're looking for the zeros, all we're looking for is those x-intercepts, right? So we can zoom in and see, hey, my graph hits negative 6, negative 4, and 3. Now, let's think about the connection there between the 0 at negative 6, negative 4, and 3. Do you see any patterns between that and our equation that we have up here? And the answer is, yeah, you should. We have a positive 6 in our factor. That corresponds with a negative 6 for our root. We have a positive 4 in our factor. That corresponds to a negative 4 in our 0. And we have a negative 3 or minus 3 in our factor. That corresponds to a positive 3 for our 0. So the key takeaway from this explore exercise is that, hey, when we have a factor with x minus a number, we'll have a 0 at that positive location. When we have a factor that has an x plus that number, we'll have a 0 at that negative location. If you want to solidify that idea further, go ahead and graph the rest of these factored forms. And even you can start making predictions about where those zeros will be based on the equation given, right? Knowing the equation, we should be able to know exactly where those zeros are on the graph. But for the sake of time in this video, I'm going to move on to notes. So if you want to do that explore, go ahead and hit pause. So our first note section here, for you, it's the connection between factored form and zeros. I just wanted you to jot down these two concepts, right? If x minus b is a factor of a polynomial, then b is a 0. If x plus b is a factor of a polynomial, then minus b is a 0. So the examples we kind of saw, right? We had, if we have a function f of x equals x minus 2 times x minus 3, then we have zeros at positive 2 and 3. And then if we went that other direction with x plus b, let's go here, we got an example, f of x equals x plus 2 this time times x plus 3. Then in this case, our zeros are at -2 and -3. So for examples 1 and 2, we have our instructions written on our note sheet. You have the example function and graph on your note sheet. No need to write anything down yet. We're going to use the graph and the equation to identify the zeros of the polynomial function. We still want to work off that connection. So if we use the graph, okay, we can see that, hey, we have a 0 here at -2, 0 at -2. We also have a 0 here at 1. Right? This is where we cross our x-axis. Okay, if we now use the equation to identify the zeros, right, we have a factor at x plus 2. Factor is x plus 2, which means we have a 0 at -2. And then we have this factor here at x minus 1. So that means we have a 0 at +1. Now, go ahead and try this on example 2. We got a different equation, a different graph. We should have 3 zeros here. And go ahead and try it and find this on your own. And then pause your screen while you're doing that. Unpause it to check your work. I'll start talking through this though, assuming that you've unpaused it. We have a 0 here at -2 graphically, 1 graphically, and 3 graphically. So I'm going to write those out. Zeros at -2, 1, and 3. And then if we want to just use the equation to solve it, all right, we have factors at x minus 1, x plus 2, and x minus 3. So I'm just going to list out our factors here. Factors, x minus 1, x plus 2, x minus 3, and that gives us zeros at +1, -2, and +3. So now that we've kind of practiced it a few times connecting the graph to the equation, we are just going to use the equation to identify the zeros of the polynomial function. So let's throw in an example here where we have the function of x equals, let's go x plus 1 times x minus 3. And we'll notice that we have a factor here at x plus 1. So x plus 1 means that we are going to have a 0 at -1. And if we also have this factor here at x minus 3, so this means we are going to have a 0 at +3. Okay, let's try this with example 4 here. Example 4. Let's throw in 3 zeros this time. Let's go x minus 6, x plus 5, and x minus 2. So in this case, we got our 3 different factors. We have x minus 6, gives us a 0 at 6. We have x plus 5, gives us a 0 at -5. And we have x minus 2, which gives us a 0 at +2. Right? And I actually probably did a bad job here. I should not have kind of written that notation here. Let's make sure we write it a little cleaner, know what we're talking about. We have zeros at 6, 0 at -5, and a 0 at 2. And if you want to, you can just start writing these as lists. So 6, -5, and 2. And over on example 3, if you wanted to write a list, it'd be -1 and 3. Okay, we are going to skip example 6 on this video, but I want to hit one more with example 5. And let's go f of x equals x plus 1, x plus 1, and x minus 3. So if we look at this, we're going to have a 0 at -1. It'll occur again at -1. And then we have a positive 3 there. And we'll learn about this later when the 0 shows up, what that means. It's called a multiplicity. But if you want to write it as 0 at -1, -1, 3, or if you want to write it at 0 at -1, 3, both of those I would accept as correct. So the final thing to really push our understanding of this is we want to write a possible polynomial function from the list of zeros provided. And we can create possible ones with really any numbers if we're given zeros. So example 7, let's just pick a couple of random ones. Let's go zeros at 2 and at -5. And if we have that, we can write a function. And I'll put my answer here in purple. That uses that 0. Oh, let me go, yeah. Uses that 0 at 2, so we get a factor of x minus 2, and then uses that 0 at -5, get a factor of x plus 5. So this 2, since it's positive as a 0, switches and becomes negative as a factor. And this 5, since it's negative as a 0, becomes positive as a factor. So let's add one more. Let's do a long one. Let's go 1, -3, 7, and -9. How about? And you should get a function already a little smaller down here that has a 0 at x minus 1. That comes from that first 0 there. So the factor is x minus 1. We get another factor of x plus 3. That comes from the 0. That was -3. We get a factor of x minus 7. That comes from the positive 7 there. And we get a factor of x plus 9. That came from that last 0 of -9. Now, make sure you show Mr. Tischer your notes. If you got them completed, you dive into practice and show those as well. And also take the exit ticket for today.